We are still working on section 16.5, and we're going to finish that section up by doing some more pH calculations. In the last video, we were looking at how to calculate pH using this equation pH equals negative log of H3O plus. And I also showed you that we can do a pOH calculation using the negative log of OH minus, and the relationship between pH and pOH. And we did a couple practice calculations calculating the pH or the pOH if we were given these concentrations of H3O plus or if we were given the concentration of OH minus. So we have a few more types of pH calculations to learn about. And here is the first type. Calculate the pH of a solution that is 6.0 molar HCl. So the calculations that you were doing in the last video, I was telling you, here's the H3O plus concentration, plug that into the pH equation. That was pretty straightforward. In this type of problem, I'm telling you, here's the HCl concentration. Now you tell me what the pH is. And this is a little bit trickier because to calculate pH, we need to know the H3O plus concentration. So what this question is really asking us, or the first thing that we have to figure out in order to be able to answer this question, the first thing we have to figure out is, what is the H3O plus concentration? And to figure that out, we're going to use an ICE table. And I know that ICE tables cause a lot of anxiety, but we're going to get good at them. They're not going to make you nervous forever. The ICE table that we're going to make is for the reaction that's taking place in a 6 molar HCl solution. 6 molar HCl means that we have HCl dissolved in water, and it's reacting with water, and the products of that reaction are H3O plus and Cl minus. And this H3O plus, that's what we need to know in order to be able to calculate the pH. The Cl minus, we don't need to know that number at all, but we're going to end up calculating it as part of this problem. So ICE table, as a reminder, the I stands for the initial concentrations of all of these different things. Initially, what we have is 6 molar HCl. I'm just going to put 6.0. And before this reaction took place, before anything happened, we had no H3O plus and no Cl minus. So prior to a reaction occurring, we had no products. I'm not going to fill out anything for water in here. And the reason that I'm not filling anything out for water, number one, as we've talked about a lot of times, water is pure liquid, which means we cannot express a concentration for water. We don't have a molarity for the water in this solution. Number two, water is in extreme excess in this situation in our 6 molar solution. Water is not a limiting reactant. It's not going to have any variable or any factor in determining what the H3O plus concentration is. So the next thing that we're going to do on our ICE table is C, the C row. Remember, C stands for change. How much is being reacted and how much is being produced. HCl is one of our strong acids, and we said that means it has a complete, total reaction. So all of the HCl that we start with is going to react. That's what it means to be a strong acid. Total reaction. The stoichiometry in this reaction is 1 to 1 to 1. So if we have minus 6 HCl, we have plus 6 H3O plus and plus 6 Cl minus. Again, that's because of the stoichiometry. Everything in this equation is 1 to 1. And so the quantity is going to be the same for everything in this equation. So now E, what we learned, this E stands for equilibrium. That's how we were using it last quarter. But we are not in an equilibrium situation right now. Even though we're using an ice table, we can say E stands for end, in this case, at the end of the reaction. When it's all said and done, we're just going to do the math in each column. So 6 minus 6 obviously is 0, and 0 plus 6, and 0 plus 6 obviously is 6. And let's not forget why we were even doing this in the first place. In order to calculate the pH of the solution, we need to know what is the H3O plus concentration. We just figured it out right there. So we have everything we need to answer this question. pH, negative log of H3O plus, negative log of 6. Stick that into our calculator, and we are going to get, I'm doing it right now, I get negative 7.8. And remember, that's okay. We're allowed to have a negative pH. There is no limit to the pH, so it is okay to be negative. It just means that this is a very acidic solution, has a very high concentration of H3O plus. So you may have noticed that the ice table is kind of unnecessary to do this calculation. All that we had to do was plug in into our pH equation the molarity of the HCl. Is what we ended up plugging into this equation. And the ice table, like I said, is kind of an unnecessary step. It's a tedious step. And that's okay. If somebody asks you to do a calculation like this, let's try another one. Calculate the pH of, let's say, 1.5 molar HBr. If you want to skip the ice table completely and just say, okay, well, the pH is going to be the negative log of the H3O plus concentration, and the H3O plus concentration is going to be equal to the concentration of the acid, and just go like that, that's totally fine. You can do that. But this shortcut that we did right here is not always going to work out for us. In the next example that I show you, this particular shortcut is not going to work.